Hey, what's up, everybody? This is Polo with Polo Trading LLC. I just want to do a quick recap of Tesla's 2020 annual meeting and battery day. And as of right now, at 6:14 p.m. Central Standard Time, for some reason or another, like I don't know, people didn't like what they saw, people didn't like what they heard because the Tesla stock is was dropping, is dropping is it was at 400, like 400. It's going up and down, but it's not looking too high. I don't know. People didn't like it. People didn't like what they hear. Maybe they wanted to hear something else. I'm not sure, but it has been dropping. So we shall see what happens, right? So I just want to do a quick recap of everything that happened, and I think it's still going on actually, but we shall see what happens at the end of this here. So let me get here. All right. So again, as the recap, and at the very beginning, it was definitely intense, and it was like a lot of people were starting to log in. At least I think got up to at least 200,000 just on the YouTube of the Tesla site, and then there was a bunch of other sites that had it as well. So it definitely was well viewed by a huge amount of people all across the world. And it had this like weird design in the back that we didn't really know what it meant. And then after it started, it came up with a video that however was already started. It was kind of weird. And then it didn't have sound. It didn't have any sound. But then they even had like this part of the video was like, oh yeah, keep your dogs in the car and keep the car at a certain temperature. So I don't know, I guess that's a decent feature. But then it also said, oh, while you're charging, you can actually play games as well. And use the steering wheel as a game controller. I don't know. That was interesting. So you got right into the annual shareholder meeting with Alan Prescott, getting finally getting the sound together, and this actually was held in front of a huge amount of people, shareholders, managers, and then several just enthusiasts as well at their facility. There was a quick video by Robin, who was the chairwoman of Tesla. That was great to meet her. And then Hero, who is a brand new, also board member, director, and on the audit committee with PricewaterhouseCoopers. Well, he's not with PricewaterhouseCoopers, but PricewaterhouseCoopers is doing their independent audit. So, and there's a lot of things that happen because you all are here for Battery Day. So I'm going to get to the point where people actually chimed in or shared shareholders actually shared certain things. They was like, hey, child labor is bad in cobalt mining. We want to see that stop. Commercial advertising is not really necessary. Tesla is a household, not necessarily a household name, but it's just a word of mouth company. They don't really need to do extra advertising. And if you try to test drive a car, test drive a Tesla, you'll get the feeling and experience, and you'll tell about it like others. And I've done that myself. The United Steelworkers actually asked for people to go against the board recommendations when it came to certain principles. But unfortunately, so I don't know if it's bad or good. I have to, I'm encouraging people to research this. Maybe this one reason why people didn't like what they heard and started, the stock started plummeting. But basically, all the board recommendations passed. And after that, there was a couple other people spoke, but then after that, Elon came up and actually shared quickly of how Shanghai went from basically breaking ground in January 2019 to now actually producing in March 2020, but basically groundbreaking the volume production in 15 months, which is incredible, which is amazing, which is uh, uh, almost, I think he said, never hasn't been done within the last 100 years. So that's incredible. And focusing mostly on the volume production of Model Y. And also just, he talked about how they introduced the cheapest solar in the US, only $1.49 per watt for solar on existing roofs. So that's pretty incredible. And then he also talked about just the 4 consecutive quarters of gap profitability, which is definitely crucial. Definitely do research on companies and what it means for their profitability. And again, consecutive. So again, that's consistent, that's consecutive. Then also consistent free cash flow generation from starting from uh, most likely Q1 2019. And I mean, they're going to continue to rock and roll. So long story short, it's been incredible. The turnaround they've been able to make from 2017 to 2019, and now 2019 charging into 2021. And one of the things he shared, Elon shared, is that there's a factory in each continent. That's a huge bonus. That's a huge benefit on, again, distribution. I talked about it in my other video on why Tesla is a damn good investment, right? Distribution, different places to get a Tesla is cuts down on the cost, right? And then also I'm talking about the industry outperformance. They are performing way better for, again, global vehicle delivery growth in the last 4 quarters. Um, just just demolishing it, right? And he mentioned how it's a 50% growth in 2019, and right now focusing are aiming for 20-30% in 2020. COVID definitely did still impact Tesla, as many of the great things that they have done and all the great things they continue to do. COVID definitely interrupted the flow. So maybe that's one of the reasons why people were like, hey, it ain't 50% growth. It's only 20-30%. I want 50% growth. If it ain't 50% plus a growth or more, hey, like old boy Charlie says, trade like a spoiled brat. Maybe people are feeling like they spoiled brats and they want more, right? So the impact is definitely huge, and you can definitely check out the 2019 impact report on Tesla's website. And also he talked about quite a few things when it came to safety and the environment. We'll get some more into that too. The average life cycle of emissions in U.S. is still pretty high when it comes to average mid-size um, vehicle. But when they looked at all of the other of the Model 3, it definitely made a difference. And safety, so and this is one thing that I've shared with other people as well. Somebody asked me about like the safety of a Tesla and the autopilot and all that stuff. So I don't know. I kind of wish they wouldn't use the word autopilot, but even if you are a pilot in an airplane, you put it on autopilot, you still have pilots. So it's not 100%, but and they say fully autonomous and things like that. I don't know, right? I'm still iffy on that about that. But the thing is, we hear about Tesla more in the news whenever there's a Tesla accident, a Tesla fender bender, a Tesla whatever, right? We hear about it more in the news because of the impact of that Tesla is making in the industry. Well, we don't hear about all of the accidents with a Toyota Corolla. We don't hear about the accidents of a Lexus or a BMW. We don't hear about all these different accidents. And they definitely exist. They definitely occur. They definitely happen. We don't hear about the accidents of a Cadillac Escalade or any car. But let a Tesla have an accident and we hear about it. People taking videos of it. People taking pictures of it, right? But with all that, still there's being able to receive a huge amount of safety acknowledgement, safety awards. It's kind of interesting in like which ones they pick, like U.S., European, Australian Insurance Institute for Highway Safety. Overall, been doing pretty well with safety, so that's a huge bonus. And then he also talked about how the factories are becoming safer. Like the amount of I'm guessing incidents, have decreased drastically from Q1 to Q4 in 2018 and 2019. Average quarterly recordable injuries per 1,000 cars produced, and this is the Fremont factory, right? Fremont, sorry, not Fremont, Fremont factory. Okay, so autopilot functionality continues to improve. And one of the interesting things that he said was he said it's kind of like 4D, 4 dimensions. So there's a 3-dimensional video, for engineers and geeks like me, the XYZ axis, right? But then there's also time. So the video is also labeling like what's going on around you in real time, and it's able to provide feedback way better, way faster. And the software had to be recreated for this. And this is one of the key elements that that Elon even shared later. We talked about how they had to not just engineer the vehicle, but actually change the manufacturing process, which is the hardest. The manufacturing is the hardest. And then he shared that Tesla is like a laptop on wheels, right? So laptops have a huge amount of software, a huge amount of computer pieces, but then we add wheels to it, right? So that's why and when creating a new manufacturing, you have to create new software. So a lot of stuff was rewritten, redone, which is incredible. And of course, again, the three different factories, the Shanghai Phase Two. I think this is I think it's Berlin. I'm not sure. And then also the Texas Gigafactory too. All right, and then he also talked about how the launch mega pack, which is a 3 megawatt uh, all inclusive, all engage energy storage solution. So continue to really focusing on harnessing the energy. Now, battery day. That's what everybody came for. Battery day. All right. So first off, they actually started off with I'm not sure if this is a picture of like a sequel to The Day After Tomorrow or some other apocalyptic dystopian movie or something. Or is this really how this area, I think that's San Francisco, I think that's the Transamerica building in California, September 9th, 2020. I think that's how, I'm not sure if this was the actual um, image, but I did hear about how the skies were orange. I did hear about how some skies were so filled with smoke that people couldn't see. And I mean, the fact that we have a fire season in America, we have a fire season, and the fact that they say, "Oh, fire season is normally in October." Now it was a month early, and they talk about how we have uh, highest uh, the highest temperatures right now. Again, that's not okay. It's not okay. Um, Highest recorded temperatures, right? Highest CO2 levels. Like somebody think like we can't keep doing this. We only got one Earth. I know Elon says he thinks it's a shame for that we are not a, multi-planet species until they did a huge. They mentioned how often they wanted to make the Tesla, the model, the regular Tesla, very affordable, right? Actually, 25,000. We'll jump ahead a little bit. They wanted to make it cost 25,000. And yeah, even with all those cost savings, I still can't. Most people won't be able to afford intergalactic travel, man, or interplanetary travel. We ain't there yet, Tesla. We not there yet. But maybe that's what he's trying to do, right? Make interplanet travel cheaper. So Drew, the senior vice president, powertrain and energy engineer. Shout out to all the engineers, especially these type of engineers, because they solve the problems of energy. He came on stage, also wearing a similar shirt with the design. Like I was like, what's this design they got? Because they really like it apparently, right? On his shirt. So he talked about that the trend in reversing, but need to accelerate. So yeah, like wind and solar compromise 76% of new electricity in the U.S. That's like 32 gigawatts. And in 2010, 46% of electricity in the U.S. was generated with coal. Today, the number is half. So we are reducing our usage of coal and increasing our usage of wind and solar. But again, it's about being able to maintain those charges, being able to maintain the energy, storing that energy up. So they said like, hey, here's what Tesla has been doing to contribute to that. So it is 1+ million electric vehicles delivered. So not just manufactured, delivered. 26 billion electric miles driven, 5 gigawatts of stationary batteries, and then 17 terawatts of solar generated energy. That's from the solar panels, the solar roofs, and some of the other devices, again, to maintain the capacity, keeping that energy to where it can be used later on. So they've been working on it. Now, they stated that to achieve the transition to sustainable energy, we must produce more affordable electric vehicles and energy storage while building factories faster with far less investment. So that's their recipe for success. There you go. And what does that look like? Goal 1 terawatt hour scale battery production. Tera is the new giga. Okay, Tera is the new giga. So I think if my memory serves me correctly, I apologize, I'll mess it up. Uh, 1,000 gigawatts equals 1 terawatt. Okay, 1,000 gigawatts equals 1 terawatt. Um, so there you have it. So in 2019, basically 100% electric transportation requires 100% growth. That's what they're looking at. So the different ways they plan on doing that. And this is one of the things they had. Let me go back. Yeah. So goal 1 is to actually create a terawatt per hour scale battery production. And this is how they plan on utilizing quite a few different things. But then the thing that was really impressive to me was right now in the Gigafactory. Okay, so for example, when they finally do get the Gigafactory up and going in Texas, basically is going to be about 0.15 terawatts, right? They'll be able to produce certain things in a certain amount of time. And investment in material, cell, and battery manufacturer is about $2 trillion. So there's a lot of money, right? And they can't get fast enough. But when you do when they turn it and increase the capacity, they'll and even still, it's still not enough, right? Because they can we can do 20 terawatts, but that's going to take at least 135 gigafactories. So the challenge is to make the factories more efficient, make the factories smaller, make the factories more profitable, all these different things, so they can actually achieve the 1 terawatt per hour factory. Um, and that's the first step. One of the first steps is, of course, more affordable sales. Right now, as you can see, like it's been going. It was up here. I'm sorry, I think I cut it off, but it's been trailing down. And it's getting better. And this is like the industry trend, right? More affordable sales. So a lot of people getting involved in sales and developing the sales. So that's helpful. But that's the problem. So I'm sorry. Goal 2 problem is that the EV market share is growing, but EVs still aren't accessible to everybody. I think they said right now only like 1% of the vehicles in the world are electric. Or maybe I don't know if that's like partial electric or totally electric. I'm not sure. But the percentage is increasing. So here we go. And a lot of people still don't have them. So I think it's like right around 1.7% of the EV market share. Yeah. So to make best cars in the world, we design vehicles and factories from the ground up. So this is what some people call like a retrenching approach. Like we just start from scratch. Like try to not necessarily throw everything away, but we will just start from scratch, or we're going to build from the ground up. And they do this with the factories, but then they also do it with the batteries. Okay, so with the factories, they are like building from the ground up. That's one of the reasons, and that's one of the reasons why they do that. So they could, some people have asked, why can't you just go somewhere that already got a bunch of factories and just redo and remake the factory, just recalibrate it, refit it, put new stuff in there? Like, nope, we want to start from ground up, so that way we can create it the way we want it, right? So that's one of the reasons why they do that. It's part of their business model. So if you are a governor or somebody trying to get Tesla to your city, or get to or your mayor or somebody, you got to have some clear land, and you might be able to get yourself a Tesla factory. All right. So like I said, they're gonna do this with the batteries as well. So here is the excitement about battery day. All right. So first part, we have a plan to have the cost per kilowatt hour. And they will do that through the cell design, through the cell factory, changing the way the factory that creates the cells, anode materials, cathode materials, and cell vehicle integration. We'll go through these real as quickly as possible. If you need to slow down the video or even rewind, by all means do that. But it's a lot of information. It's a lot. So I don't want to bore you. Let's get it. So the typical battery, right? Most people understand what a battery is because they've had one or seen one. It's a positive and then the negative, right? That's simple. Now these are important: the anode, the cathode, separator. So the anode is the positive end, the cathode is the negative end, but it's connected. The separator keeps everything connected within. And then while it's being discharged, that's how the like for example, the lithium goes from positive end to negative end, and when it recharges, it goes from the cathode to the uh, positive end. So that you can get more into that later on, and that's one thing. Like that's the flow of battery energy, right? It expands and then it's replenished. All right. So now what they're planning on looking at is changing the size of the battery, and changing the height as well as the energy that can be stored in it. Um, so 1865 is just the diameter and the height of the battery, and that was back in '08. Now currently they start using the 2170, which is started in 2017. Again, it's diameter and the height. And basically that dubbed that like well it created energy 50% better than the original batteries. Well, now the thing is, if they do go with a bigger cylinder, they end up the bigger cylinder sales cost less. So that's one of the great things about a bigger cylinder. And what they actually, but now the issue with the big cell is that it is more challenging to charge. So you most likely won't have a supercharged big battery, right? But what they plan on doing is actually creating a new type of cell and decreasing that cost exponentially. This is one of the huge aspects of battery day right here. Supercharged time increase goes down drastically. All right. And they talked about how when the one reason is that the charge time actually has tabs. Okay, they really high. It takes a lot of energy to recharge one of these, and because they have tabs. Well, the new style will not have tabs. Okay, the new style of battery they plan on designing will not have tabs. Now, I'm still trying to figure out what all these things mean. I got a degree in engineering, but it was engineering management. So, but and now we actually find out what is the actual shirt. The actual shirt is these things here, right? These are uh, different pieces that have been put together to create this new battery, right? It's more simple, fewer parts, and it's 5 times the reduction in electrical path. That means that the amount of time it takes to get from one end of the battery to the other has been greatly reduced. And these are layered. Okay, these are layered. So instead of having a tab, we have layers that are intricate in each cell. So that's one of the huge aspects of this. And with that being said, this is the I don't remember if they said 4680 or 8046. As you see, 88 millimeters, 46 millimeters are. I'm not even sure what that. I don't know if that's millimeters. Don't quote me on that. That might be mega. I don't know. Don't quote me on that. 8046, 5 times the energy, has a 16% range, and 6 times the amount of power. With that itself, it reduces the amount per kilowatt hour by 14%. That is a huge cost of savings. It's not about how much money you make, it's how much money you keep. And that will help reduce the amount of energy that is used as well. So that is a huge benefit. So then they went into the cell factory, right? Because the factory itself is pretty challenging on how to create these type of batteries. You have the electrode, then you have it wound up, then you have the assembly portion, putting the top on it. and then the formation. So in this process is actually pretty long. There's a huge amount of chemistry, a huge amount of electrical engineering, chemical engineering, civil engineering, a huge amount of different types of engineering that goes into this. And if you could imagine going through phase one, then phase two, then three, then phase four, then phase five. Like it's a huge amount of back and forth, back and forth. I remember learning that the more times you touch a product, the more expensive it becomes. The more time you touch a product, the more expensive it becomes. So what they're doing is what we call in the industry lean engineering, or either Six Sigma, reducing waste, all these fancy terms. Shout out to everybody that's a green belt and Six Sigma. Um, and what they're doing is instead of having what we call a electrode with the wet process, right? I'm not going to listen. I actually have a minor in chemistry, so I understand what they're talking about, right? And even dabbled with chemical engineering for a while, but I don't want to bore you all with this. You all want to figure out, like, is this still a good investment or not, right? It is, trust me. Wet process is actually into a dry process. The less you have to touch a product, the better you can do. So you start with a dry electrode, mix it, and then create the dry coat. 10 times the footprint reduction, right? Again, you're touching it 10 times less. Imagine that, touching something 10 times less. But it also creates 10 times energy reduction, right? So again, touching something 10 times less, and you spend less energy trying to create that as well. So that's what this is for dry electrode. And also within this facility, they talked about high-speed continuous motion assembly. So right now, they can actually be able to create one assembly line instead of all those different, like, back and forth, back and forth, back and forth, back and forth. They'll create one assembly line, developing 20 gigawatts per hour, and have 7 times the line output. That is, again, major. That is major. And when you reduce the number of assembly lines, then you only need one assembly line to do the same amount of work as multiple assembly lines. So what does that look like? Well, it looks like 80%, 86% reduction in formation investment. That means you have to invest less in your facilities to get the same output, and 75% less formation footprint as well, which means that you actually, in 2018, the Gigafactory is 150 gigawatts, right? It produces 150 gigawatts. A Terafactory would actually be smaller and produce more energy, 10 times smaller footprint per gigawatt hour. So a terawatt, the terafactories are going to be smaller than the current gigafactories. Okay, so the future factories, again, those who are city planners, mayors, governors trying to get new industries into your state. Again, if you figure out you got some land or got some place, like, that is good for Tesla, I'm telling y'all may want to check them out. And hopefully other car industries, other car manufacturers are following this, because Tesla actually shared or said that I don't understand this process part, right? But he said that he actually made the patents available for people to examine, to look at, to understand, and he's encouraging manufacturers to, like, hey, this is what y'all probably want to do if y'all want to stay compatible. Like, if y'all don't want to be able to compete, if y'all want to be able to compete with me, these are some of the changes y'all might want to do. If y'all don't want to do them, okay, fine. All right. So again, the plan is to have not just 100 gigawatt hour plants and 100 gigawatts in 2022 to get the gigawatt factories to 100 gigawatts per hour, and then to get the plants to 3 terawatts per hour, okay, by 2030. 3 terawatt per hour factories by 2030, okay? So after the battery itself and the cell and the cell factory now we had a 32% per kilowatt hour reduction. So now we go to the annoyed material. So this is one of my favorite parts because it's all about, again, the chemistry of it. So the most abundant element in the crust after oxygen, guess what it is? It's lithium. And actually, lithium stores 9% more, and it stores 9% more lithium than graphite. Um, so the crust is full of lithium. We don't have to worry about running out of it anytime soon. I do not know. I don't know how exactly how much it is in the ground. I'm not sure, right? But it's a huge amount. And current approaches to silicone. So let me rewind. So um, I'm sorry, silicone. Silicone. Silicone is the next after oxygen in the crust. Silicone, not lithium. I'm sorry. All right. Um, Current approaches to silicone are highly engineered, expensive materials. Um, it just costs a lot to deal with silicone, but it's extremely abundant. And by the way, I mean it's sand, right? Huge amount of sand everywhere. All right. And it can actually be structured and created into other things. Well, this didn't work out well, but right now the process is pretty mucky. Okay, we'll keep it moving. Process is pretty mucky. So instead, they actually created a whole entire different way for expansion and the use of raw silicone to increase the range by 20%. So you have the raw silicone, and you stabilize the surface through the process that they created. Okay, and then it's highly elastic and it has electrode design as well. So it's just extremely great engineering there. So by doing that, that reduces by 37%. So that was incredible, like a total. Right now we had a total. So now that was the no. Now we got to do the cathode. Right, the cathode is also another piece of the cell itself. Um, so, and they mentioned how like cathodes are like bookshelves, right? So you imagine battery, it has a casing, but then it has all the stuff in the middle, right? That's monkey, that's moldable, that's moving, all that, but you have the stuff on the outside. Well, um, uh, pretty much usually is a metal, and depending on the type of metal, will determine the price or determine how great it is, or even the best structure, right? So again, if it's like a bookshelf, is it like a wood bookshelf or metal bookshelf, right? Which one's gonna hold more? Okay. So with that being said, the metal cost is right now nickel still provides, to my understanding, the best, but other things, cobalt is there and iron there too. So what they actually are trying to do is uh, have is doing what they can when it comes to dealing with the nickel and other things like that. But then also because right now they're trying to, like, I guess, remove the cobalt, and there's a lot of other things, right? So you can definitely go check it out, and they'll break down a lot more of the science. But when you have nickel, you're able to do way more stuff, right? You're able to do way more things. So, and you're gonna have still need different type of ores or alloys for the product, right? For different products. So, therefore, we will see how they utilize iron when it comes to the factories, or nickel and manganese for long range production for vehicles or long range vehicles. But then high nickel will still be utilized for the cyber trucks and semi trucks. So those, again, like, they plan on really focusing on a lot of nickel companies. And again, and they made it clear that, like, hey, we don't produce these batteries ourselves. We rely on a lot of our partners. They kept mentioning Panasonic, so that's another good company to probably be investing in. It'd probably be another good idea to look at, like, the nickel, cobalt, iron companies, lithium companies. They mentioned how they actually have um, uh, purchase a desert, or not, or purchase an area in Nevada to get more lithium. So that was pretty incredible. So right now, the manufacturing process is a big target. So now, as you see right now, they doing 35% nickel, 25% lithium, 5% cobalt, but the processing of all that is 35%. So that's where a lot of the cost going to when it comes to batteries in themselves and the cathode itself. And the tradition is, again, it's a lot. It's a bunch of stuff, huge amount of processes, and it's just it's just a lot of chemicals. A bunch of stuff happens, but the again, this is the traditional one. The new process will eliminate a lot of the waste of the raw materials. It will recycle some of the raw materials, and again, less stuff happens when it comes to the production. So, and as you see under the final product, it'll be way less wastewater and way less byproducts. Again, so leaving a better footprint, an eco footprint, while creating these. Also, again, the less you touch something, or the more you touch something, the more expensive it is. The less you touch something, the less expensive it is. So they actually are able to get a greater product with fewer touches. Incredible. I'm not sure if people understand it or not. No, we shall see. And then they even said the factories will be better for it too. All right. So then directly consuming nickel powder simplifies metal refining and recycling, because right now it's a nice amount of waste. They do a pretty good job, right? And they do plan on having places where batteries can be recycled with little to no harm on the environment. So sustainably mined sourced ores, optimized refining and recycled batteries. They talked about that. Eliminates billions in battery grade nickel production. So that's another great thing. And they said as some of the batteries that will be last for at least 10 years will begin to need to be traded out. So they'll figure it out. And like I said, they talked about having lithium clays in Nevada. They plan on having a Tesla cathode. Cathode. I don't know why I keep saying the wrong cathode. I forgot where they said they're making it at, but they'll have a factory just for that, and it's continue to receive nickel and lithium from different places. But again, it takes a lot to ship those different things from different places from here to there. So they actually will be working towards having the Tesla lithium and cathode places right next to each other. They plan on getting the lithium clays directly from Nevada, and minimizing where they get some other stuff. So a reduction in lithium costs will be down by 33%, and the factories will be 100% electric facilities. So that's another great thing. And again, it talked about getting lithium. Lithium is apparently easy to get. However, there's actually enough lithium in Nevada to electrify the entire U.S. fleet. So basically, I'm not sure what mining facility or who will be responsible for this. I definitely will be looking and investigating, and might even be investing, right? But the lithium mines in Nevada, they just got those, and they'll be doing the process there. So again, instead of having to transport lithium raw materials and doing all this other stuff, they just go take it right there and have it placed. So again, just great reduction on everything. Recycling resource is 10 years delayed. So again, in 2025, batteries available for recycling. Because they started in 2015, they're going to start recycling batteries 2025. So they had to make sure they had to take care of that, figured it out. And with that, right now we had a 49% kilowatt hour per reduction, saving a huge amount of money, saving a huge amount of cost. And now one of the other big things is that the casting, right? A lot of people already talked about the casting already. Right now, the Model Y giga casting. So the challenge is you have to create, and if you want to have a cast, you have to create the machine to create the cast first. That's why manufacturing is really hard. You got to get that really, really right. And right now they was doing mostly the rear underbody by doing a cast. And when you do a cast, it's, again, way less pieces. and you can get it done quicker. So it actually reduced 79 parts per car. That's huge. That's huge. If you think about every single piece of a car, and then you reduce that by 79 pieces, you're able to produce cars faster, get them out faster. Well, um, uh, they actually are created. This is where they created a new alloy, no heat treating or coatings. Okay, so I'm not gonna go into too much detail again because I would definitely geek out on this. I would definitely geek out on this stuff. But long story short, if you can imagine, um, a muffin pan, right? Or have you seen in cooking shows and somebody put too much batter in one of the muffin holder, one of the muffin things, and it cools off too soon or it's too thick or whatever, right? That's one some of those a huge amount of the challenges with casting, right? So if you want to have your alloy thick in one area but thin in another, right? That's really tricky. That's really tricky. All right, so that's why they had to create a new alloy. So again, that's incredible there. Like I don't, that's phenomenal. So that's something um, that we could look at that's going to drive the cost down even more, especially if they create a whole entire cast instead of just a rear end. One of the other aspects is that they said, well, they looked at how original airplanes once had aircraft wing, and the wing was partially storage. And then it had an excess structure, like it was just stuff there. And then they realized, and now somebody came along and said, well, why don't we just create the storage the size of the wing, right? Like the shape of the wing, instead of creating the storage and then having a bunch of leftover space, let's create the storage to fit the wing, right? So that's what they did. They said, oh, well, the batteries, the battery should actually be part of the structure, and to be able to provide storage. So structural batteries improve mass and range. What that means is the revolution in body plus battery engineering. So 10% mass reduction. It made the car lighter, 14% range increase, and then 370 fewer parts. It's 370, 370 fewer parts. Again, the more you touch something, the more expensive it is. The less you touch something, the less expensive it is. Like this is a lean engineer, Six Sigma, like everybody, like this is our wildest dreams right now, right? So be able to create a cast of where you just eliminate a lot of these different things will be way better. And again, simpler, smaller, integrated battery plus body factory of the future. So uh, a gigawatt hour, 55% reduction in investment per gigawatt hour, and 35% reduction in floor space. Again, smaller but more powerful, which leads to a 56% kilowatt per hour reduction. Um, that's incredible. That's a huge amount of savings in the development. Now the challenge is, and this is what people probably also don't like. I mean, they were being honest. Like, they was like, hey, like this ain't like some of the things we are already in the midst of doing. Other things will take maybe a year and a half, 18 months, and for us to really recognize the benefit and the cost, it might even be 2-3 years. So don't get overly excited. This will take time. It will take investments. It will take messing up, but figuring things out. So, but the range will increase. The kilowatt reduction will continue to be reduced, and the investment per gigawatt reduction, the investment is 69%, which means they saving more money, so they can invest back into the company. So our investments actually will be better too. So again, this is phenomenal for those who are deciding to be long-term investors. You are trying to trade this quick, fast, and hurry. I don't know what's going to happen. New trajectory, right? So again, originally, everybody was trying to figure out how to get on this, and the industry trend was going down and doing pretty well, and forecast was like, oh, we'll get there by 2025. No, Tesla was like, no, we're gonna get there even sooner. So way more reduction, and they are actually, again, they sharing information. They talking about sell equipment manufacturers, new and existing sales suppliers. They continue to work with Panasonic and many others. Raw material manufacturing, mine engineers, all that. Electric vehicle powertrains that cost less than combustion engines. Again, they are trying their best to get to $25,000 cost, and they expect that from 3 years from now, right? And extreme performance and range. They showed a video of the Plaid Model S, which was on a run. I forgot. It was on one of the racetracks. You can go on Tesla.com and watch the video. It goes super fast, 0 to 60 in 2 seconds or less. It does like it's 200 miles per hour. I don't know why they make cars 200 miles per hour. I guess for if you take your car over to Europe and on the Autobahn or something. I don't know. You can't drive nowhere in America at 200 miles per hour. Maybe at a test site or something. I don't know. Anyway, but that's pretty much it. Like that was the battery day, right? So some people were really excited about it. Some people weren't. So we shall see what happens, and and at the end of at the end of the day, some people are going to be excited. Some people are going to be enthused. Again, long term. This is for the long haul, for the long term. I'm not sure when. And they asked a bunch of other questions. They had a Q&A session. They asked a bunch of other questions. They said, "Hey, like, what's up with the sound and the audio in the vehicles?" And they was like, "Well, people will get. It'll come with title. So maybe title. If you want to invest in title, that might be a good look." People asked about the Cybertruck, things like that. So it was going to be other catalysts coming around too, the Cybertruck, the semi-truck, things like that. And again, at the end of this, and now it's at 7 p.m. on the dot. And right now the stock is still at $395. So we shall see if it continues to change. But like I said, some people were excited about it, some people not. We shall see in the morning what happens. So that's the recap for the annual meeting and the battery day. Let me know, comment, press the like button, share with others for the recap. Let me know what you think, right? Let me know if you think that this is a good investment and we should get this right now, or we should wait for another year to see what happens. I don't know, right? I'm not an investor. All these images are trademarked to Tesla because I just was watching this and copying and cutting and pasting and cropping out videos, stuff like that of the video real time, so I can be able to produce this video for you all as soon as possible. So I hope you all actually appreciate this, and I'll see you all next time. Check out my other videos, especially the $100 ARK ETF challenge. I'm super excited to see how this battery day actually impacts some of the ARK ETFs. I can't wait to hear what Kathy Wood has to say about this as well. And I'm just looking forward to see what happens. So therefore, I see you all later. God bless. Many blessings. See you.